So let's start with supervised learning. There are two main kinds of supervised learning, regression and classification. Here's a little example about how they differ. If you were trying to predict what tomorrow's temperature is going to be, if you are a weather forecasting station or something, you might use a regression model to try to predict tomorrow's temperature. You might base it on things like today's temperature and today's humidity, today's precipitation. You could use a set of variables, and then you're going to try to predict what is tomorrow's temperature. But the key point is that tomorrow's temperature is a number. It's a precise number. It could be 84, it could be 84.5. Whereas in classification, what you're trying to predict is not a precise number, it's a category. So is it going to be hot or cold tomorrow? Looking at this example, you might think that regression is just better because it's more precise, but really it just depends on the situation that you're facing. For example, if you're making a little widget for a mobile phone where it shows tomorrow's temperature, you might want to save some space and add a little emoji with a classification of whether tomorrow's temperature is hot or cold or in between. And that could be a category that you're going to predict and save space for the user. Anyway, there are much better uses of classification than that. But the gist of it is that you're not trying to predict a real number. You're trying to predict a category. It could be hot or cold, or it could be one of several categories. It doesn't have to be just two. So in summary, supervised learning, you feed a set of data and it learns from the relationship of some explanatory variables, a set of data that you might use to explain the patterns of the prediction variable. So you're going to try to tie maybe 5 to 10 to 100 variables and how they all tie together into predicting a single one in the most classical definition, let's say. Regression is for numbers and classification is for categories. So 2 examples. If we want to predict today's ice cream sales in a big ice cream store, we could try to do that based on a temperature forecast. So we could feed a historical data set of what is the median temperature of a day, and then what was the daily ice cream sales for that day as well. If we do that for, let's say, the past year, we could try to fit a model with that data, and then tomorrow we can just press play on the model and get a prediction for what does the model think will be today's ice cream sales based on today's temperature. And that is the gist of regression. This is a very simple example. And then an example for classification, we could try to predict whether a loan applicant will default. So in a bank, when someone is applying to a loan, the decision of whether to approve it or deny it is a classification. It's are we going to say yes to this loan applicant, or are we going to say no? And then what you do in this scenario is that you feed the model with a historical data set of several variables, explanatory variables like applicants, credit score, education level, and income level, and many others. This is just an example. But then each applicant you would put together with the historically accurate value for whether it was a good or bad idea to approve the application. So you would be pairing the profile information with whether it was a good decision or whether it was a bad decision. And then the model will infer the relationships between how does education level together with income level, for example, affect whether the application is good to approve or not. That yes or no decision can be taken or suggested by a classification model. So in mathematical terms, what regression and classification look like in simple models, in simple models is like you have numerical data for the regression, and then all of these pink dots here are the different data points that you are using to train your model with. And then the model is just some mathematical function. If you remember functions in school, a function can look like this, like a straight line, or can be a curve. But it's just a model that takes in the information from the historical data set and finds some shape or pattern within that data, so that when you paint a new dot here, or let's say that this is let's say that this is years of age of a person who walks into a store, and you're going to predict you're going to spend in the store. In this case, the older the person is, you will expect that they will spend more in the store because, well, in this imaginative scenario, the older person has more savings and more funds. Whereas in classification, you're not trying to predict a number using a function like that. You are trying to you're trying to find patterns in the data that allow you to draw something like this curve here that will allow you to make a decision. So if the set of variables that train the model yield something that is below this threshold, like in here, it could be that your model will decide to not approve the loan. And then the ones in here, the model will decide to, yes, approve the loan. So it's not going to find a number, it's going to draw a decision threshold for deciding between the different categories.